today's lecture, we are going to learn about applications of CRO. There are variety of applications of CRO. Now we will see one by one all the applications of CRO. First one application is measurement of time period. As on the screen of the waveform we can see the different type of waveform. By observing that waveform we can measure the time periods or time period of particular waveform. Then next is frequency measurement. As the first application is the time period measurement, so time is inversely proportional to the frequency, so we can measure the frequency with the help of CRO by varying the time per division knob. Then next is amplitude measurement. Amplitude or voltage. We can vary the volt per division knob and we can measure the amplitude of the waveform on the screen of a CRO. Phase measurement. It is also most useful application. We can measure the phase of a single waveform or phase difference between two waveforms. AC voltage measurement or RMS voltage measurement also possible with the help of CRO. Next, DC voltage measurement. Component testing. As there are different types of components are available in electronics field like LED, semiconductor diode, transistor, etc. Such type of component can be tested with the help of CRO. In television, as a magnetic deflection system, this is also one of the application of CRO. In radar, in ships, this radar application is used in ship or aeroplane to detect the position of the object from the target. Radar is nothing but radio amplification, detection and ranging. And in medical instrument like ECG, electrocardiogram, EEG, electroencephalogram, EMG, electromyogram, such type of different instrument also available as a applications of CRO in medical field. And last one is the distortion measurement. This is also one of the most important application of CRO. Now let us see all the application in detail one by one. Now for measurement of voltage and frequency we have two knobs, volt per division and time per division. Now we'll first see how a voltage is measured. Whenever a waveform is displayed on the screen of CRO, a voltage is always measured as peak to peak voltage. See, this is a positive peak to negative peak. It is denoted by peak to peak voltage and this is scaled on y-axis. Okay. Now following procedure is followed while measuring the voltage. What to do? Now first count number of divisions in vertical directions on axis, which corresponds to peak value. Suppose number of division is equal to 4. Now note the position of volt per division knob. See this position of volt per division knob Let us assume it is 1. What will be the formula to calculate the voltage? That is peak to peak voltage, that calculate the voltage peak to peak equal to number of divisions on y-axis and multiply by volt per division. Now we know the volt per division knob is at 1 position while number of division equal to 4. Therefore peak to peak voltage is equal to 4 volts. We now measure frequency and time period of a waveform. As the peak to peak voltage can be measured with the help of y-axis. In the similar way, we can measure time period and frequency both on the x-axis or in horizontal direction for a complete 1 cycle of an AC on the screen of a CRO. Following procedure is followed for measuring the frequency of the waveform for a 1 cycle. Let us count the number of divisions for 1 complete cycle in horizontal direction on x-axis. Let us assume number of division is equal to 4 with the help of the graph. Now note the position of time per division knob. We have two ranges to measure time per division, millisecond and microsecond. Now let us assume time per division is equal to 1 millisecond. So calculate the time period with the help of formula. The time period is equal to number of divisions multiplied by time per division. That is equal to 4 multiplied by 1 millisecond and time is given by 4 millisecond value. As we know that frequency and time both are inverse to each other. Therefore, we can write the formula F is equal to 1 upon T, as T is equal to 4 millisecond. By putting the value of T in the formula, F is equal to 1 upon 4, and that is equal to F is equal to 250 kilohertz. Now we have to learn about the phase difference measurement with the help of CRO. See, this is the screen of CRO. You can see there are two different waveforms. To find the phase difference, it is necessary two waveforms should be displayed on the screen. And the formula is phase difference in division multiplied by degree per division. There is no special knob for degree per division. As you can see the waveform on the screen, there is a distance between these two sine waves. See, this is for black and this is red. The distance between these is equal to 2. So, the phase difference in division is equal to 2 divisions. Is that clear? Now, see, this is a complete cycle. We have to find out degree per division. Now, how to find out degree per division? See, there are two sine waves. If we have to count number of blocks for complete cycle and how much is degree for a cycle, See, this is 90 degree, 180, then 270 degree, and finally it is 360 degree. So the complete cycle is about 360 degree. Now this complete cycle takes 360 degree, and how much divisions takes this cycle on the screen? Let us calculate. Total number of divisions are 8. So 8 divisions takes for 360 degree cycle or complete cycle. Hence 1 division. Now by putting the value of 1 division is equal to 360 upon 8. So we get the value of the degree per division. Okay. See, this is the value of degree per division. We will put this value in the formula of phase difference is equal to phase difference in division multiplied by degree per division, that is denoted by letter phi. We know phase difference in division, that is 2 divisions. Now by solving the equation we will get 2 1s are 2, 2 4s are 8, and this is equal to 4 1s are 4, 4 9s are 36. So the value 90 degree, and the phase difference in between these two waveform is equal to 90 degree. Got it all of you? In this way we can measure phase difference. This is the second method to find out the phase difference, and the name is LJES patterns. By using LJES pattern we can find out the phase difference between two waveforms. In this method, two sine waves of same frequency are applied to CRO. One to the vertical plate and other to horizontal plate. The CRO is said to operate in XY mode. Now, the obtained pattern is known as LJES pattern. The LJES pattern will be an ellipse. See, this is ellipse. If the sine wave has phase difference between 0 and 90 degree, then the ellipse is formed. So, the phase difference can be calculated with the help of formula theta is equal to sine inverse A upon B. It is necessary to find out the value of A and B with the help of screen. See, this is A, first touch of the ellipse to the y-axis, and B is the peak of the ellipse parallel to the y-axis. So we can find out the phase difference with the help of LJES pattern with the help of this formula. As you can see the special cases of phase difference between the waveforms. First one is the if phase difference is 0 degree or 360 degree, then you can see the line. If the phase difference is 90 degree or 270 degree, so you can see the circle on the screen. If the phase difference is 180 degree, you can see the line in this fashion. So in this way, we can measure the phase difference with the help of LJES patterns. We will see in the laboratory, electronics laboratory, more about this application. So I think all of you understood very well the last method, that is phase measurement using LJES pattern. Thank you.